Right, so section 4.5, okay, that's on using congruent triangles. So the idea in this section is first you got to prove the triangles are congruent, and then we're going to do one extra step kind of after that. Okay, looking at these two triangles, could you prove them congruent?
Yes.
Yeah, and what would be the way you'd do it? Side, side, side. Okay, so using the above diagram, if you wanted to prove those triangles are congruent, you could. But let's say I asked you to prove that angle PQS, okay, the one up at the top on the left, and RQS, the one at the top on the right. I wanted you to just prove those angles are congruent. Well, they're not marked congruent. And you don't have parallel lines and transversals, so you can't directly prove these angles are congruent. Okay, but what you can do first is show that the triangles are congruent by side, side, side. And then once you prove that two triangles are congruent, the corresponding parts of two triangles that are congruent match up. Okay, so we have a name for that. So you show your triangles are congruent, then use the fact that corresponding parts of congruent triangles are congruent. Corresponding parts mean sides or angles. So corresponding parts of congruent triangles are congruent. And since that's kind of a lot to say, we'll just abbreviate it CPC, TC. Okay, but you can only use that theorem after you've proven triangles are congruent. So the statement right before this should be something like that. And then whatever your side, 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 whatever your reason was. Okay. Any question on that idea? Okay. Now, once you prove that those triangles are congruent, we could say angle PQS and RQS match. We could say QPS and QRS, those angles match. Any of the angles match. Okay. Once we show that they're congruent. Okay, so that's pretty much all we're going to look at today. So we'll try a few examples doing that. All right. So they've given us some information here, but they didn't mark it in the diagram. I like to mark it in the diagram, because for me, visually, that's easier to see. So AB is parallel to CD. Okay, and BC is parallel to DA. So BC and DA. Does anybody know what kind of shape that is? Two pairs of parallel sides? It could be a rhombus if we knew all the sides were the same length, but we don't know that yet. Yeah, it's a parallelogram. Two pairs of parallel sides. That makes it a parallelogram. And if we know a shape is a parallelogram, that actually means all kinds of things, which we're going to learn later on. All right, so they want us to prove segment AB and CD are congruent. So the first step is we've got to show that these triangles are congruent.
That doesn't look right. It should be AB and DC.
Well, we'll go through it and we'll see if the letters match up. We'll see. All right. So what could we say first? Yeah, let's start out with the givens. Okay? Because then from those, maybe we can talk about alternate interior angles or some kind of angles. Okay, but we got to say what was given first. So AB is parallel to CD, and BC is parallel to DA. That's given. Okay, step 2. Now that we know we have those parallel sides, is there anything here I could say about some angles? Marquise? Sure. What, can you name two alternate interior angles there?
We go ABD.
Okay, so ABD, let me write that down. ABD is congruent to what?
BDC.
BDC. Okay, let me write that down. Let's see if the letters match up. So he started out with A, then went to B, then went to D. All right, so we started out at, let's see, what was your other angle? BDC. All right, so we started out at B. Okay, what you said there is fine. I'm just not sure that if we were to write congruent, I don't think we could say triangle ABD and triangle BDC are congruent.
You don't say triangle, same thing.
You see what I mean?
You say angle.
Right, I understand that that's an angle. But if we start out here, probably should have started out there. Okay, probably should have said something like CDB. I think that would have been matching up the letters, but that's okay. All right, so that's alternate interior angles. And that's not the converse, just the theorem. Okay, do we have anything else there for alternate interior angles?
Can't we say BD? Segment BD is congruent to segment BD?
We can, yep. But if we're going to talk about angles right now, let's do everything we have to do with angles, and then we can talk about a segment. But yes, we do need to talk about that too. So what other angles are congruent here? Yeah, go ahead.
ADB.
All right, so ADB,
CBD.
and then, let's see, CBD. Yeah, I think that one's good. Okay, let's write that down. And it's the same reason we already have. So angle ADB. So we started out where the two pairs of parallel sides meet, so we'll do the same thing on the other side. C, and then what were the other letters you said, Marquise?
BD.
CBD. Same reason. Okay, so now we have angles. Now let's say what Connor just said. He already mentioned about BD being congruent to itself. That is a new reason. Okay, that's not reason 2. So we need a new statement. And Connor, what's the reason for that?
Reflexive property.
Yeah, that's the reflexive property. That side is shared in each triangle. Okay, now I think we've proven the triangle's congruent. Somebody give me a way you could name the triangle on the left. Yep.
Triangle ABD.
All right. So he said ABD. Now we got to be careful with that order. So go ahead.
It's congruent to BDC.
All right. So he went A, then the single, and then the double, and then go ahead one more time.
BDC.
Yeah, we can't do BDC.
I have to say CDB.
So yeah, if we start with ABD, then we got to go to the one that doesn't have any, which is C. Then the next letter was the one that had the single. So we're going to go to the one that has the single mark, which is D. And then the third letter was the one that had the double. Go to the one that has the double. B. Okay. Any question on that?
Reason.
Just like said, like if those two sides were parallel right on top, that those sides were congruent as well, because if AD is parallel to BE and AB is parallel to DE, then like no matter if they weren't the same length, then those two lines at the top would be parallel, or if the ones at the top weren't the same length, then those two lines at the bottom would be parallel.
Yes, that is true. We don't know that yet, but yes, that is true. The definition of a parallelogram, if you have two pairs of parallel sides, opposite sides are also congruent. They have to be. But we just haven't proven that yet. But yes, that is true.
So could you just say that, and like, these triangles are congruent because the two sides are the same, and one angle is already, they tell you that one angle is the same, right?
They did tell you, no, they didn't tell you any angles were the same. They just told you that you had two pairs of parallel sides.
Or you could just say those two lines are congruent, and then opposite angle or opposite interior angles, and then also.
Yes, that is true that, again, BC and AD, they are congruent. But we just can't say that until we talk about parallelograms. For now, we have to just use one of the four reasons, like angle, angle, side, or so on. Yeah. But eventually, we will talk about the definition of a parallelogram. So what's our reason here for congruence? Yep, angle, side, angle. Okay, now we can go back and say what they wanted us to prove. AB and CD are congruent. Okay, that's kind of what they wanted us to actually show. We can say that. We now know that they are congruent. So AB is congruent to CD. What's the reason for that? Yep.
C, P, C, T, C.
Yes. Corresponding parts of congruent triangles are congruent. So we proved that the triangles were congruent, so all their parts that correspond are congruent. Okay. Any question on that? Because that's the new step, CPCTC. Okay, and you could do that with, instead of just AB and CD, you could have done it with the top and the bottom side. Same reason. You could have done angle A and angle C. Could have proved those congruent now. CPC, same reason again. CPCTC. Those are all corresponding parts of congruent triangles. All right, take a look at this one. So this one has something to do with midpoints. Okay, it says A is the midpoint of segment MT, and A is also the midpoint of segment SR. This one's a little different. They want us to prove lines are parallel. So think about what that means. When we're trying to prove lines are parallel, a lot of times do we end up using one of the theorems we learned in that section or the converse of it? So the converse of a theorem is probably going to come up here. Maybe if we can prove alternate interior angles are congruent, then the lines are parallel. Okay, but to do that, first we got to show we have two triangles that are congruent. All right, so what should my first statement be? Yep, say the givens. So A is the midpoint of MT. And I'm going to say them together. A is the midpoint of segment MT, and it's the midpoint of segment SR. Given. Okay, let's work with that a little bit. What does that mean? Let's start with if A is the midpoint of MT. Yep.
Segment MA is congruent to segment TA.
Yep, MA and TA are congruent. Anything else I can say at the same time? It's going to be the same reason. Yep.
SA and RA.
SA and RA, yes. And the reason there, what's the reason that they are congruent? Let's mark them. That's the definition of a midpoint. Okay, definition of midpoint. Okay, so now we've got two sides. And I don't think we're going to be able to get a third side, so maybe we should start thinking about an angle here. Yep.
Angle MAS and angle RAT are congruent.
Angle let's see, so you said M-A-S, okay, and which one?
RAT.
R-A-T. Those are congruent. What's your reason there?
Vertical.
Those are vertical angles. All right, so let's mark it. We have that, and we have that. And now I think we have enough information to say the triangles are congruent. Let's just be careful with the order. Okay, the order is the trickiest thing to figure out. Okay, let's start with the triangle on the left. You can use any order you want here. Doesn't matter. Yep.
Angle MAS.
Okay, so now he said MAS. Now we got to match that up.
Step 3.
Yep.
RAT.
All right, let me write it down and then let's check it. Let's start with M. So M is the vertex where the side that's empty and 2 come together. The side that's empty and 2 come together. Is that one R? No, it's T. Okay, so if you had that as statement 4, that part wouldn't be right. Okay, so again, look at M. It's where the 2 and the empty come together. The 2 and the side that's empty come together. So start with T. And then A. A is the vertical angle. On the other side, A is the vertical angle. And then S. S is the side where the empty one and the 1 tick mark come together. Empty and 1 come together. That's R. So I didn't say anything when we did the angle, because technically it's okay. But in the 4th step, it wouldn't be. Now we're good. Okay, what's my reason?
Side.
Good, side angle side. Okay, so now we've proven that the triangles are congruent. That means that angle M matches R. Okay, all kinds of, angle M matches T. S matches R. Okay, everything matches up here. So what would I have to say to prove that MS and TR are parallel? What would I have to say next? Denver?
You have to use the angles.
Yep, you got to say something about angles. I would probably think about showing alternate interior angles are congruent.
That's what I thought.
Can somebody name a pair of alternate interior angles here? And I think single letters will suffice. Yep.
Angle M and angle T.
Yep, let's look at our picture. Perfect. M and T match up. They are congruent. Angle M is congruent to angle T. Okay, I'll mark that. What's the reason?
Alternate here.
Well, we don't have parallel lines yet. So we can't say that those necessarily would be congruent because of parallel lines. But there's another reason why M and T have to be the same now. Yep?
CPCT.
Good. Step 5, the reason is CPCTC. You prove the triangles are congruent, so all their corresponding parts are also congruent. Now step 6. I think we can say what they wanted us to prove. MS and TR, they are parallel. Now what's the reason for that? And be careful when you say the reason. Yep.
Alternate interior angles, Converse.
Right. That's the alternate interior angles converse. That one word at the end there can make it right or wrong. So the converse says if alternate interior angles are congruent, then the lines are parallel. We've proved it. And And I think that's about as short as you're going to get that proof. That's about it. Okay. Any questions on that proof? Okay, and I know sometimes they do seem kind of hard, and the only way to really get good at them is to practice. And I'm not going to give you a proof that isn't fairly similar to something we've done in class. So most of the proofs you see on the test, we're going to have done something very similar in class. It's not like I'm going to give you a proof for the first time and it's going to be a totally different proof that you've never seen. All right, so it's going to be all the same reasons you already know. All right, let's try this one together, and then maybe I'll let you try one on your own. All right, so they're giving us some parallel lines. And they're also telling us that those parallel lines are congruent. So MS is parallel to TR, and it's also congruent. And they want us to prove A is the midpoint. Okay, they're not giving us that we have to prove that. A is the midpoint. So sometimes what I like to do is work backwards from the proof. Okay? If A is the midpoint, what would that mean in that picture?
Yeah, M and T.
Yeah, if A is the midpoint of MT, what would that mean?
That MA and TA are congruent.
Right, that would mean that MA and TA are congruent. And think about what those are. Those are sides of a triangle. So if you can show the two triangles are congruent, then that would automatically mean MA and TA are congruent, which would automatically mean A is the midpoint. Right, so that's kind of the direction we want to think about going in. All right. So what should we start off with here, as always? Yep, start off with the given. Let's say MS is parallel to TR, and MS is congruent to TR. Okay, so we at least have a side. Anything else I could say based on those lines being parallel? So this is a little different. We do know they're parallel this time. We're not trying to prove that.
Angles are
Yep, which angles would be congruent?
angle M,
Mm-hmm.
angle T.
Good. Let's write that down. Angle M and T are congruent.
Couldn't we say S, angle S, and R congruent?
Yep, you could also say that. Angle S and R. Those are congruent. And what's the reason for that? Again, this is one of those reasons you've got to be very careful how you say it.
Converse.
Nope, this one's not the converse. Yep, this is just alternate interior angles. The converse is used when you're proving lines parallel. Lines parallel was given, so we're not going to use the converse. Alternate interior angle theorem. All right. Do we have enough information to show those triangles are congruent? Yeah, we do. What didn't we even use this time that we... Yeah, we didn't use the vertical angles. You could have. That would have been a different way to do it. Angle, angle, side. That works. But we didn't do it that way. We did angle, side, angle. All right, so now we can say, let's do triangle. Which one? MSA, okay. Now, can somebody else match up the three letters that Connor just said in the other triangle? he said MSA. So, yep, Katrina? Yes. He went from the blue, red to vertical. So T, R to A. I don't know why, but for me, that's always the toughest part, trying to figure out the order of the three letters. I don't know. And the reason? Angle, side angle. Yep. All right, now we've really done a big part of this proof. We've proven the triangle's congruent. So I think we have two statements left. What would be my next statement that I could say that would lead me to the fact A would have to be the midpoint? Yep?
MA and TA are congruent.
Right, MA and TA have to be congruent now. First, third, first, third. So he said it perfect. MA is congruent to TA. And what's our reason for that?
Because that's the definition of congruent.
It is the definition of congruent triangles, but right. The corresponding parts, which is what he said, first, third, so corresponding parts of congruent triangles, which we have from step 3, match up. They are congruent. And now I think we got it. If MA and TA are the same length, A would have to be right in the middle. So A is the midpoint of MT. And that's the definition of a midpoint. Okay, I don't think you're going to get this proof any shorter. Only thing you could have done different is talked about vertical angles, but I actually think that would make the proof longer, because then you'd need a separate reason for that. We combine two reasons, two statements into one reason, step 2. Any questions on that proof? All right, I'll put up one more, and I think that'll be the last one we'll do. Okay, so in this picture, let's see, they're telling you that angle 1 and 2 are congruent, and angles 3 and 4 are congruent. And let me outline in red what they want you to show. Show that BCE is congruent to DCE. Any, notice what they gave you there. Okay, they gave you something about two triangles that are not part of what they want you to prove. That means that chances are your proof is going to somehow involve these other two triangles. Maybe. All right? But you might have to look at triangles here other than the ones I outlined in red. Okay, so take a second. Look at that. This one might be a little tricky. We'll see. See if you can figure it out, and then we'll go over it together. Right, so looking at this triangle, since they're giving me some information, angles 3 and 4, that has nothing to do with the two triangles I want to prove congruent, I probably need to use that information somehow. Okay, so what I'm going to do to start is I'm going to focus on that triangle and that triangle. Okay, those two separate ones. Okay, so let's look at those. All right, so we know that a couple things are given. Let's write them down. Angles 1 and 2 are congruent. So 1 matches 2. Angles 3 and 4 are congruent. So 3 matches 4. What's the reason for both those statements? That was all given. Okay, so now I have an angle matching an angle in the top and bottom, another angle matching an angle. What else could I say, something that's used in both of them? Yep.
CA is congruent to CA.
Sure. CA is congruent to CA. That's your reflexive property. All right, so now I have enough information to show the two triangles I outlined in green. Those are congruent. Let's just make sure we try to say the letters correctly. Let's start with triangle ACD. Okay, what would that be congruent to? Well, let's look. So we started at A. So you start at the double. Start at the double at the bottom. Yep. Triangle A. Then we went to the single. And then D was the one at the top that had no mark. B is the one at the bottom with no mark. And what's my reason for that? That's an angle side angle. Okay. Step 4. What do I know about side CD and CB now? They are congruent. So I'm labeling things in red that weren't proven, but we figured out. Why is CD and CB congruent? Ian?
CB, C, TC.
Right. Those are corresponding parts of congruent triangles. Okay, so I think we almost have enough information. We have a side, an angle. We have a side and an angle. We need one more piece of information. And I think we have it, and we've already used the reason earlier. Okay, so on your own, when you're writing this kind of proof, that's what you would have just needed to figure out in your head. The hint that I just gave you. Yeah?
CE is congruent to CE.
Yes.
Reflexive property.
CE is congruent to CE. That's an E. So let's mark it. And that's the reflexive property. And I think we've proven it. Write down what we had to prove. Triangle BCE is congruent to DCE. Reason? Yep, side, angle, side. SAS. Okay, so a little tricky. It's the first time we've ever had to do something like that, but I hope I've done enough proofs that at least you have a lot of ideas of things you can try when you're trying to prove stuff on your own. Okay, so there's not a lot of problems tonight because they are mostly proofs. It's 4, 8, 9, 10, 8 through 10 all, and 14 to 18 all. Okay, so next time I see you guys on Friday, we'll have our test. And the test will be on 4.3 to 4.5.